Hey everyone, and welcome. Today we're going to take a super quick journey straight up, climbing through the invisible layers of our sky to really understand what's going on up there. So, let's start climbing.
So right off the bat, here's the big puzzle. You know how when you go up a mountain, it gets colder, right? Simple. But what if you just keep going up, all the way to space? Well, the temperature doesn't just keep dropping. Nope. It goes up, then way down, then way back up again. It's a total roller coaster. And unlike air pressure, which just gets lower and lower, the temperature is kind of all over the place. Why is that?
The key to this whole mystery is a concept called the temperature gradient. Now that sounds super technical, but it's really not. It's just a fancy way of saying how much the temperature changes as you move. And what's so cool is that this one simple rule is exactly how scientists draw the lines between each layer of the atmosphere. Every single layer has its own unique temperature trend.
Okay, our trip starts right here on the ground, in the layer we all know and love, the troposphere. And as you can probably guess from its nickname, the weather maker, this is where pretty much all the action happens.
This is our home turf. It's where we live, it's where we breathe, and it's where we get all of our weather. We're talking clouds, rain, storms, the whole shebang. And the most important thing to know is that the temperature here does exactly what you'd expect. The higher you go, the colder it gets. And that's because its main heat source is actually the ground right under our feet. But hold on a second. That feels a little backwards, doesn't it? I mean, the sun is up there, blasting all that energy down on us. So shouldn't the top of this layer be the warmest part? Why on earth is it getting heated from the bottom up?
Well, here's how it works. A lot of the sun's energy actually passes right through the air and gets soaked up by the ground. The surface is just way better at absorbing it. Then the ground heats up the air that's directly touching it, kind of like a giant frying pan. And you know what happens to hot air? It rises. As it rises, it expands and cools off, and that creates that classic gradient of getting colder the higher you go.
Okay, let's climb up past the clouds and all that weather. We're now entering the stratosphere. This layer is home to things like the jet stream, and as we're about to see, it's basically our planet's most important shield.
And this is where things get weird. The moment you cross into the stratosphere, that temperature rule does a complete 180. It actually gets warmer the higher you climb. This is exactly why commercial jets love flying up here. It's super stable, and you're above all that bumpy weather. It's smooth sailing. So what is going on here? We just learned the rule, hot air rises and cools. What in the world could be powerful enough to completely flip that process on its head? The answer, in a single word, is ozone. That famous ozone layer, the one that protects us from sunburns, it lives right here in the stratosphere. Its whole job is to catch the sun's most dangerous, high-energy UV radiation. And when it absorbs that energy, it converts it directly into heat. It's like having a giant space heater floating in the middle of the sky.
All right, let's keep climbing. We're punching through the top of the stratosphere and entering the mesosphere. If the stratosphere is our shield, you can think of the mesosphere as our planet's frontline defense against space rocks.
Here in the mesosphere, or the middle layer, the temperature trend flips. Again, it starts getting colder and colder the higher up you go. And this layer's big claim to fame? This is where most meteors, what we call shooting stars, burn up from friction, creating those amazing light shows in the night sky.
And when I say it gets cold here, I mean it gets really cold. The very top of the mesosphere is the single coldest spot in our entire atmosphere. We're talking a bone-chilling minus 90 degrees Celsius. That's about minus 130 degrees Fahrenheit. Unbelievably cold.
So why this extreme deep freeze? We're getting closer and closer to the sun, but this layer is an absolute icebox. What's causing this crazy temperature drop? It really just comes down to how thin the air is. Up here, the air is so incredibly thin that there just aren't enough gas molecules to absorb the sun's energy. There's no ozone layer to act as a heater, and it's way too far from the warm ground. So it's basically unheated, and it just gets colder and colder as it gets further away from the warm stratosphere down below.
Okay, we've made it. We're at the very top deck of our atmosphere, the thermosphere. This is the huge, final frontier, the gateway to outer space.
And get ready for one last temperature flip. The thermosphere gets insanely hot. Temperatures can soar up to thousands of degrees. This is where the International Space Station and other satellites orbit, and it's where we see the incredible auroras. But here's the crazy part. Even though it's technically super hot, if you were there, you'd freeze. Why? Because the air molecules are spread so far apart, sometimes miles apart, that they just can't transfer that heat to you. It's a real paradox.
Now, this layer is so enormous that it's actually split into two different subregions. and they're both pretty fascinating. First up is the ionosphere. This is where the sun's radiation is so intense that it zaps atoms and creates electrically charged particles called ions. And it's these charged particles that interact with Earth's magnetic field to create those stunning northern and southern lights. Then, way above that, you've got the exosphere. This is the final, wispy edge of our world, where the atmosphere doesn't really have an end. It just fades away and leaks out into the vacuum of space. So let's bring this all back home. The one thing to remember from this entire journey is this. It's not about how high you are or how much pressure there is. The one single rule that defines the entire structure of our atmosphere is the temperature gradient, whether it's getting hotter or colder as you go up.
And hey, if you want a really easy way to remember the order of all these layers, starting from the ground, just remember this little phrase: that snake must think. That's troposphere, stratosphere, mesosphere, thermosphere. It's a super handy trick to keep it all straight.
So from the storms brewing right above our heads to the meteors burning up miles and miles away, this incredibly complex, layered shield is what makes all life on Earth possible. Which really just leaves us with one final big question. We know this amazing structure is built on a delicate balance, so what happens if we start to change it?